सर ये जो असाइनमेंट है पीएल वाली जो, वो कर रहा हूँ मैं सर, लेकिन मतलब दिन में स्पीड बहुत स्लो है सर, लेकिन समझ रहा हूँ कि कैसे क्या है, मतलब कर लूंगा लेकिन स्पीड अभी स्लो है तो।
ओके, द प्रॉब्लम इज के स्पीड स्लो है, समझ में आ रही है, सवाल भी हो रहे हैं, पर स्पीड बहुत स्लो है, बहुत टाइम लग रहा है, करेक्ट?
हाँ सर, जैसे सोल्यूशन में है ना, कि जैसे सोल्यूशन में क्या है कि सपोज करो लॉन्ग बाय क्रोन से किया पहले, ऑब्जर्व लॉन्ग आ गया, एक पीएल मिल गई, उसके बाद में इसने ने जो है कि डी लेट डी लॉन्ग निकाल के रन लगा के देन ईपी पे जाके फिर इसने किया है। मैं जो है कि जैसे सीधा कर रहा हूँ कि पहले ऑब्जर्व लॉन्ग ले लिया फिर रन लगा दिया प्रैक्टिकली, देन ऐसे मतलब अलग ढंग से कर रहे हैं कि जरूरी नहीं है कि इसी को फॉलो करना है।
दैट्स राइट बेटा, बिल्कुल सही है,
ठीक है सर।
बिल्कुल सही है। बाकी जो टाइम ज्यादा लग रहा है बेटा, उसका तो एक ही इलाज है, एक ही उसका सोल्यूशन है। आप पहले तो उसे जितना टाइम लग रहा है उतने में करो, क्योंकि पहले तो आपको सवाल करना आना चाहिए। ओके, एक बार आपको सवाल करना आ गया, यू नो दिस इज द कॉन्सेप्ट, दिस इज हाउ इट इज टू बी डन, फिर आप जैसे जैसे उनकी प्रैक्टिस करते जाओगे टाइम धीरे धीरे नीचे आता जाएगा। सो फर्स्ट कंसंट्रेट ऑन फाइंडिंग द करेक्ट मेथड एंड आंसर। Once you get that, then concentrate on practicing questions. अगर चाहो तो पहले इन्हीं क्वेश्चंस को दूसरी बार कर सकते हो, आपका टाइम जो है इम्प्रूव हो जाएगा। Then maybe you can jump into other questions which you get from past papers or anywhere else. So जितने प्रैक्टिस करते जाओगे टाइम इम्प्रूव होता जाएगा।
ठीक है सर, ओके सर, पहले इसको कंप्लीट कर लेते हैं असाइनमेंट को देन।
हाँ, इसे मत छोड़ना बेटा, ये तो पहला स्टेप है, इसे कंप्लीट करना। Once you are satisfied with this, then you jump into other questions.
ओके ठीक है सर, ओके थैंक यू जी।
Okay. So beta, last lecture we had covered up stars suitable for observation and इसमें हमने 3 टाइप्स के क्वेश्चंस जो हैं वो देखे थे। पहला क्वेश्चन था फाइंड द स्टार्स विद इन ए सर्टेन आर एंगल ऑफ द ऑब्जर्वर मेरिडियन। दूसरा क्वेश्चन था कि जो स्टार्स हमने फाइंड किए हैं इनमें से कौन से विजिबल हैं हमें और कौन से सूटेबल फॉर साइट हैं। एंड जो तीसरा जो हमने कॉन्सेप्ट देखा था दैट वाज कि इन स्टार्स में से कौन से एक्स मेरिडियन के लिए सूटेबल हैं। सो ये 3 टाइप्स हमने की थी। टुडे वी विल बी मूविंग इनटू टाइप नंबर 4 एंड टाइप नंबर 5। ये जो दोनों टाइप्स हैं इनमें क्वेश्चन जो है वो चेंज हो गया है, इट इज ऑल टुगेदर चेंज्ड। पहले क्वेश्चन जो है एक ही लाइन पे चल रहे थे, 1 2 एंड 3 वर बेस्ड ऑन द सेम प्लेटफॉर्म। अब जो है ये थोड़ा सा डिफरेंट है। सो इसका जो कॉन्सेप्ट है वो थोड़ा सा अलग हो जाएगा। Instead of a R angle, they will give us a time period and they will tell us to find the stars crossing the meridian. So ये हम अभी देखने वाले हैं। So go ahead बेटा।
सर जो असाइनमेंट दिया था उसका तो फर्स्ट क्वेश्चन था, उसमें जो सॉल्यूशन है ना, सॉल्यूशन में उनमें सेकंड नहीं लिया, उसने टाइम को जो लिया जीएमटी टाइम वो केवल आर और मिनट में लिया, बट सही में उसका सेकंड्स में भी आ रहा है, तो सेकंड लेना पड़ेगा ना सर।
ट्वाइलाइट टाइम बेटा?
हाँ ट्वाइलाइट टाइम सर, ट्वाइलाइट में फिर अपन एलआईटी निकालेंगे तो सेकंड्स में आएगा।
बेटा आप चाहो तो सेकंड में भी ले सकते हो, बट जो ट्वाइलाइट के टाइम्स हैं, सनराइज सनसेट मूनराइज मूनसेट के हमारे पास के जो टाइम दे रखे हैं, they are only accurate up to minutes. So if you want you can round it off to the nearest minute. If you want you can include seconds also, no issues, both are correct.
फिर जो दूसरा क्वेश्चन था सर, उसमें आपने बताया था कि अपन जो प्लेनेट है उसके लिए भी ऐसे देखेंगे अपन, जो लेफ्ट साइड का पेज है उसमें नीचे वो राइट साइड में दिया ना 3, बट जो सॉल्यूशन है उसमें उसने जीएचए से किया है सर, तो जीएचए से मैच किया।
Not required, not required from GHA, you just have a look at it from the daily page, it will be done.
और सर एक क्वेश्चन था उसमें ट्वाइलाइट टाइम, उसने नॉटिकल ट्वाइलाइट के टाइम में ना वो पूछा था अपना ना, तो उसमें ऐसे निकालना था। तो एक जो थर्ड क्वेश्चन में है उसमें उसने ट्वाइलाइट का टाइम लिया सनसेट से लेके नॉटिकल तक का, बट फिफ्थ क्वेश्चन में वही सेम क्वेश्चन है कि स्टार सुटेबल फॉर ऑब्जर्वेशन, उसमें उसने लिया सिविल एंड होने से लेके नॉटिकल एंड होने तक का सर।
अब बेटा ध्यान से सुनना जो मैं कहने वाला हूँ। अगर कोई क्वेश्चन आपको बोलता है फाइंड द स्टार्स इन नॉटिकल ट्वाइलाइट, ओके, नॉटिकल ट्वाइलाइट, nautical twilight is clear, it is 0 to 12 degrees, 0 to -12 or -12 to 0, whichever way. Nautical twilight is from 0 to -12 or -12 to 0. ये पूरा पीरियड nautical twilight में आता है। That is statement number 1. अगर किसी क्वेश्चन में वो आपको बोलता है nautical twilight and suitable for sight, तो इसमें दोनों कंडीशन आ गई। तो हमें 0 to 12 का पीरियड तो नॉटिकल में मिल गया, लेकिन इसमें जो सूटेबल फॉर साइट होता है वो होता है -6 to -12। 0 to -6 इज नॉट सूटेबल फॉर साइट। तो अगर ये वर्ड यूज किया गया है सूटेबल फॉर साइट, you pick up the period from -6 to -12 or -12 to -6, whatever applies. Okay बेटा?
जो सुटेबल फॉर ऑब्जर्वेशन है उसके लिए अपन वो नहीं देखते सर, एल एंड डी का डिफरेंस लेस देन 80 होना चाहिए।
बेटा दोनों अलग अलग चीजें हैं। एल एंड डी का डिफरेंस आपको ये बताता है कि जब स्काई में स्टार दिखेंगे तो वो आपकी होराइजन के ऊपर होगा या नहीं, वो ये बताता है। -6 to -12 आपको ये बता रहा है कि स्काई में स्टार दिखेंगे भी।
इसमें मतलब वो क्या बोलते हैं अपना, नॉटिकल टॉयलेट टाइम लेना है, फिर विजिबल भी होना चाहिए, उसके ऊपर एल एंड डी का डिफरेंस लेस देन 80 भी होना चाहिए, वो तीनों चीज आएंगी
सी
इसमें।
सी एल डिफरेंस डी, अबव होराइजन बिलो होराइजन, कम लेटर ऑन बेटा। पहली चीज है क्वेश्चन में कि टाइम कौन सा लेना है,
ओके सर।
सनसेट टू नॉटिकल, सिविल टू नॉटिकल, क्या लेना है, वो पहली चीज है बेटा। पहले तो आप उसे फाइनलाइज करो ना, वो तो बाद में देखेंगे कि एल डिफरेंस डी मैच हो रहा है, सूटेबल फॉर साइट है, एल डिफरेंस डी लेस देन 80 है कि नहीं है, दे एवरीथिंग विल कम लेटर ऑन।
ओके सर, ओके सर।
ओके ओके। अब बेटा ये जो डाउट है ये मैंने बता तो दिया, पर ये अभी हमने किया नहीं है, अभी हम दूसरे वाले सवाल करेंगे उनमें ही आएगा। सो अगर किसी को नहीं भी समझ में आया, डोंट टेक टेंशन, अभी आज के 2 पार्ट जो है वो कर लेते हैं, उसके क्वेश्चंस आप प्रैक्टिस करो, आपको डाउट आएगा मैं फिर समझा दूंगा। ओके नो फॉर प्लैनेट्स, देखो आप प्लैनेट के लिए चाहो तो 15 डिग्री ले सकते हो। ओके 15 डिग्री इज कंसिडर्ड एक्यूरेट। अगर किसी को बहुत ही ज्यादा एक्यूरेट चाहिए, नॉट रिक्वायर्ड इन द क्वेश्चंस, अगर किसी को बहुत ही ज्यादा एक्यूरेट चाहिए तो फिर आप उस 15 डिग्री में प्लेनेट की वी करेक्शन जो है उस दिन के लिए वो अप्लाई कर सकते हो, बट दिस मच एक्यूरेसी नॉट रिक्वायर्ड इन आवर क्वेश्चंस। हमारे क्वेश्चंस के लिए आप प्लेनेट के लिए 15 डिग्री का रेट यूज कर सकते हो। ओके सो चलें बेटा, टाइप 4 एंड 5 पे चलें। ग्रेट, लेट्स गो बेटा। सो बेटा ये है लास्ट क्वेश्चन जो अब आप स्क्रीन पे देख रहे हो, जो हमने किया था। इसमें हमने फाइंड किए थे कि कौन से स्टार 15 डिग्री के अंदर हैं आर एंगल, और फिर हमने देखा था उनमें से कौन से सूटेबल फॉर साइट हैं, और लास्ट में हमने ये पता किया था कौन से एक्स मेरिडियन के लिए सूटेबल हैं। सो दिस वाज द लास्ट क्वेश्चन व्हिच वी डिड। नाउ वी आर प्रोसीडिंग अहेड, मूविंग टू द नेक्स्ट क्वेश्चन।
Now, there may be situations or questions in which we may have to find stars and planets which cross observer's meridian within a given interval of time.
Beta,
For example, this one, in position 40.
Is the audio video working fine?
No, sir. Can you start again?
Is audio video very good?
40 degrees 10 minutes north, 121 degrees 15 minutes east. Find the stars and planets of second magnitude and brighter crossing observer's meridian between 1800 hours to 1900 hours ship's time, zone time -0800 hours on 21st September 1992.
You can give a reading to the question. Let me know if any doubts are there. Okay, beta. Great. So proceeding ahead.
To handle such questions, we need to obtain the SHA of an imaginary star on the observer's meridian, both at the beginning of the given interval and at the end of the given interval. So we get two SHA values of this imaginary star. One when it is on the observer's meridian at the commencement of the interval, and second when it is on the observer's meridian at the end of the interval. We know how to calculate the SHA of imaginary star on the observer's meridian. We can equate the LHA of that imaginary star to 360, and this LHA is equal to LHA Aries plus SHA of the imaginary star. We have already calculated in the first question, and we can repeat that process out here. If the duration of time is not given in the question and it is only AM or PM twilight, then for AM cases, the interval used is between the starting time of the nautical twilight to the starting time of the civil twilight. So that shall become the interval. Commencement of the interval shall be at the onset of nautical twilight, and the ending of the interval shall be at the start or onset of the civil twilight. For PM cases, this interval shall be between end of civil twilight to the end of nautical twilight. We can identify the stars and planets within the SHA range thus obtained, corresponding to the magnitude of stars and planets that is given in the question. Now, all the stars within this range shall be crossing the observer's meridian during the given interval. Whether they shall be visible or not, or whether they shall be suitable for taking sight or not, or whether they shall be suitable for X-meridian observation or not, we know once we get a comprehensive list of all the stars and planets, we can do the further analysis depending on whatever may be expected of us in that particular situation.
Now, beta, all these steps we will be doing practically in a question. So I'll be showing you all these steps and explaining you how these steps are taken. So shall we move ahead?
So that's fine.
Okay.
Okay, sir, go ahead.
Okay, beta.
Or particular question. So now we're in a position where we can solve this question. In position 40 degrees 10 minutes north, 121 degrees 15 minutes east, find the stars and planets of second magnitude and brighter crossing the observer's meridian between 1800 hours to 1900 hours shift mean time, zone time -8 on 21st September 1992. So we first find out the GMT at the commencement of the required interval and GMT at the end of the required interval. So the starting time, ship's mean time is 21st day, 18 hours. Zone time -8. And we get GMT, longitude is GMT least, 21, 10, 0, 0, 0, 0. So we get the GMT at the commencement of the interval. Likewise, we calculate the GMT at the end of the interval, 21, 19, 0, 0. Zone time -8, and we get GMT as 21 day, 11 hours, 0, 0 minutes, 0, 0 seconds.
Okay, so beta, there were two times which were given to us, 1800 and 1900. We are required to find the stars which are crossing the observer's meridian between these two times. So for 1800, we found out the GMT time. 1900, we found out the GMT time. Any doubts up to here? Great. Let's go ahead.
Now we get the LHA Aries for these two GMTs. So at the starting time, GHA Aries for 21 hours, 21 day, 10 hours is so much. Increment is 0 because it is 0 minutes, 0 second. We get GHA Aries as 150 degrees, 31.9 minutes. We apply observer's longitude to it. Longitude east DHA least, we add the longitude, and we get the LHA at the commencement of the required interval as 271.46.9 minutes. That is the LHA Aries at the commencement of the interval. We get the LHA Aries at the end of the interval. You can see the values coming up on the slide. You can also check them from your almanac. And we get the LHA Aries at the end of the interval. Now we find out the SHA of the imaginary star on the observer's meridian at the starting of the interval and at the time of the ending of the interval. So for imaginary star on the observer's meridian at the commencement of the interval, LHA star, which is equal to 360 degrees, will be equal to LHA Aries of 271 degrees 46.9 minutes plus SHA star, which gives us the value of SHA star to be 088 degrees 13.1 minutes at the commencement of the required interval. Exactly the same way, we can get the SHA of the imaginary star on the observer's meridian at the end of the interval. And we get this value to be 73 degrees 10.6 minutes.
So beta, we have
The
found
video
out
is not
that,
audible.
ask again beta.
Pause किया भाई.
Any doubts up to here beta?
No sir, continue.
Okay, all right. So basically beta, we have found out the SHA of a imaginary star on our meridian at 1800 hours is 08813.1, and at 1900 hours the star on our meridian is with a SHA of 07310.6. So this simply means that all the stars which have their SHA between these two values, 88 degrees and 73 degrees, came on our meridian between 1800 and 1900. Right, beta?
Right sir, right.
Right. So let's go. So it becomes very simple now. We have got a range of SHA from 07310.6 to 08813.1. Rest of the question is exactly same. We go to page 268, star table, find out the stars within this range, and that's our answer. Let's do that.
We have got the SHA of the imaginary star on the observer's meridian at the commencement of the interval and at the end of the interval. So all our stars and planets of interest should have the SHA in this range. So the SHA range that is of interest to us is from 073 degrees 10.6 minutes to 088 degrees 13.1 minutes. We go to the star tables and we find out stars of second magnitude and brighter in this SHA range. And for planets, we'll go to the daily pages of the Nautical Almanac for 21st September. Stars and planets of second magnitude and brighter crossing given observer's meridian between SMT 18 to 19 on 21st September. The stars will be only two. You can check. We already have learned this, how to figure out these stars in the star tables in the range of SHA. And the stars are Vega and Cos Australis. These are the two stars in this SHA range meeting this magnitude requirement as per the question. And when we go to the daily pages of the Nautical Almanac for 21st September 1992, we find there are no planets with SHA in the given range on that day. Therefore, we do not have any planet which is going to cross the observer's meridian in this window. On the other hand, we have two stars of magnitudes of second magnitude and brighter, which shall cross this meridian of the observer between 1800 hours to 1900 hours. Now, we have already calculated the stars, whether they are going to be visible or not, whether they are going to be suitable for sight or not, or whether they are going to be suitable for X meridian limits or method or not. I think we have to execute the respective step further if we have to assess them for any other parameter which we have learned, be it their visibility, be it suitability for sight in general, or be it their suitability for ex-meridian observation.
So in this question, star
Planets
Vega
which
is
shall
0.1
to
magnitude.
suitable.
Its first magnitude star.
Ask again, beta.
Sir, Vega is magnitude is 0.1. It is first magnitude star, but in the question they want second magnitude star. Correct?
Beta, with second magnitude, they have also mentioned and brighter. So that includes first magnitude also.
Okay, got it. Sorry.
So have a good look, beta. Let me know any doubts coming in. Usually, see, beta, there can be many stars which are suitable between 1800 and 1900. So they have to specify something. They will have to ask crossing term in the question. So without that, question will become very vague. Beta, if they are asking stars available for sight, in that case, we will have to get the criteria of L difference T less than 80. Because any star below 10 degree altitude will basically not be available. Okay, we will not be able to take the sight. If he asks you which all stars will be visible or which all stars will be above the horizon, then L difference T less than 90 will be the criteria.
सर इसमें और पहले किसमें यही डिफरेंस है ना कि उसमें टाइम हमको निकालना पड़ा था, इसमें टाइम दिया हुआ है बस, बाकी सेम ही है.
नहीं बेटा, बहुत बड़ा डिफरेंस है. इससे पहले वाले जो तीनों क्वेश्चन किए गए थे उनमें एक ही टाइम दिया गया था. Only one time was there. Yes, in this question there is a interval of time, there is a period of time, 1800 to 1900. That is the big difference.
Exactly ऐसे ही आता है सर ये क्वेश्चन, मतलब इसी टाइप.
Yeah, this is how the question comes, beta.
ठीक है सर, ओके.
सर अभी थोड़ी देर पहले बोले थे अगर टाइम इंक्लूडेड नहीं रहेगा तो हम लोग सिविल टू नॉटिकल का टाइम ले लेंगे ना एल्मेनक से सर.
राइट बेटा.
ओके ओके सर.
सर सेम जैसे यहाँ पे हमने स्टार्टिंग टाइम एंडिंग टाइम अलग बना के अलग निकाला है, उस केस में हम लोग स्टार्टिंग ऑफ सिविल नॉटिकल जो भी रहेगा वैसे दो बना के वैसे एसएच स्टार का रेंज बना लेंगे, राइट?
एग्जैक्टली बेटा. अगर ये इंटरवल आपको ना दिया गया हो और आपसे पूछा गया हो कि स्टार्स बताइए क्रॉसिंग द ऑब्जर्वर्स मेरिडियन ऑन सो एंड सो डेट इन द एएम और पीएम, तो आप सिविल और नॉटिकल के दोनों टाइम उठाओगे और उनको 1800 और 1900 की जगह पे रख दोगे एंड यू विल सॉल्व इट.
ओके सर.
एग्जैक्टली बेटा. जहां पे क्रॉसिंग आ जाएगा आपको एक पीरियड ऑफ टाइम चाहिए, फ्रॉम दिस टाइम टू दिस टाइम. एग्जैक्टली बेटा, यू गॉट इट राइट.
एक्सक्यूज मी सर, सर ये क्वेश्चन नंबर 4 जो आपने था असाइनमेंट का सर, इसमें ये पूछ रहा था दैट स्टार्स विल बी अवेलेबल फॉर ऑब्जर्वेशन बिलो
बेटा
द कोर.
1 मिनट, 1 मिनट रुक जाओ बेटा. सारे के सारे डाउट असाइनमेंट के ये खत्म करने के बाद लेते हैं बेटा। इसमें क्लियर है आपको ये जो क्वेश्चन है? दिस इज क्लियर ना?
हाँ यस सर।
बस जरा सा रुक जाओ बेटा, लेट मी कंप्लीट नंबर 5, फिर मैं आपके सारे डाउट असाइनमेंट वाले पिक कर लूंगा। ओके ग्रेट, सो लेट्स मूव अहेड बेटा, लेट अस सी द नेक्स्ट टाइप आल्सो।
For X meridian limits or method or not, I think we have to execute the respective step further if we have to assess them for any other parameter which we have learned, be it their visibility, be it suitability for sight in general, or be it their suitability for X meridian observation. Having found the stars and planets which shall cross the observer's meridian within a given interval, we could similarly be required to find the stars and planets that shall cross the observer's inferior meridian during the given interval. Observer's inferior meridian is the meridian which is 180 degree opposite to the observer's own meridian. Say for example, this question. In position 40 degrees 10 minutes north, 121 degrees 15 minutes east, find the stars and planets of second magnitude and brighter crossing the observer's inferior meridian between 1800 hours to 1900 hours ship's time, zone time -8 hours on 21st September 1992.
So just read this question beta, let me know if any doubt is there.
ऑब्जर्वर्स इंफीरियर मेरिडियन मतलब सर ये एक्स मेरिडियन बोल रहा है?
नहीं बेटा, इंफीरियर मेरिडियन का मतलब होता है ऑपोजिट मेरिडियन, रेसिप्रोकल मेरिडियन। If you are on Greenwich, inferior meridian is 180 meridian.
Okay, sir.
Okay, so let's see the solution.
Now, for such cases, we'll have to obtain the SHA of an imaginary star, which is on the observer's inferior meridian this time. Not on observer's meridian, but on observer's inferior meridian when at the commencement of the interval and at the end of the interval. For imaginary star on observer's inferior meridian, the LHA, because the imaginary star is on the observer's inferior meridian, so the LHA of the star in this case shall not be 360, but it shall be 180. So the difference lies here. In the earlier case, to find the SHA of the imaginary star, we were equating LHA to 360 degrees. In this case, because the imaginary star is not on the observer's meridian, but on the observer's inferior meridian, so the LHA of the imaginary star shall be equated to 180 degrees. If the duration, like the previous case, is not mentioned in the question, then for AM, the interval shall be between the start of the nautical twilight to the start of civil twilight, and for PM, it shall be the end of the civil twilight to end of the nautical twilight, which has been explained earlier. Identify stars and planets of the required magnitude within the SHA range, thus obtained like the previous case. All stars having SHA within this range will be crossing the observer's inferior meridian during this period. It does not mean that they need to be visible. It does not mean they'll be suitable for sight. But yes, what they would be doing is they would be crossing the observer's inferior meridian. Now, here comes an important change. Out of these stars, only those which are circumpolar will be visible to the observer. Because when the celestial bodies cross the observer's inferior meridian, then they shall be above the observer's rational horizon only if they are circumpolar. Otherwise, they will be below the horizon. So only those stars and planets which happen to be circumpolar shall be visible if we have to ascertain the visibility issue. A star will be circumpolar only if latitude and declination are same names, and at the same time, that is plus, the sum of latitude and declination is greater than or equal to 90. So out of the stars that you list, only those would be visible which are circumpolar.
Okay, beta. So we will be doing all these steps in a question now. So I will show you how these steps are done. So any doubts here, or shall we proceed ahead?
So I have doubt in the circumpolar concepts here. Last step.
Okay, what's the doubt, beta?
So how this L and D difference will be more than 90 degrees?
Okay, all right. So you mean to say how has these conditions been derived? Correct?
Yes, sir.
Okay.
Yes, sir.
We will do that, beta. After this topic, we will be going into circumpolar bodies. So I will show you how these conditions are derived. Okay, we will do that in detail. For this purpose of this question, just remember that these are the conditions. That's all.
Okay.
Okay, great. So let's proceed ahead.
Now let's solve this question. In position 40 degrees 10 minutes north, 121 degrees 15 minutes east, find the stars and planets of second magnitude and brighter crossing observer's inferior meridian between 18 to 1900 hours SMT, zone time -8 hours on 21st September 1992. So first we get the GMT at the commencement of the interval, and you can see the SMT 21 day 18 hours, zone time -8, GMT 21st day 10 hours, and we get GMT at the commencement of the interval. We get the GMT at the end of the interval, which comes to 21 day 11 hours 00 minutes 00 second. Now we get LHA Aries for both these GMTs. GHA Aries at commencement time is 150 degrees 31.9 minutes. We apply the longitude east, GMT least, we add it, and we get LHA Aries as 271 degrees 46.9 at the commencement of the interval. Likewise, we get LHA Aries at the end of the interval. You can see it on your screens, and LHA Aries comes to 286 degrees 49.4 minutes. Now we get the SHA of an imaginary star on observer's inferior meridian at the commencement of the interval and at the end of the interval, and same is obtained by equating the LHA of the imaginary star to 180. You can see here LHA of the imaginary star is equal to 180, LHA Aries is 271, and putting these values, we get the SHA of the star as 268 degrees 13.1 minutes. Likewise, we get the SHA of imaginary star on the observer's inferior meridian at the end of the interval, and we put the values, and we get the value of the SHA as 253 degrees 10.6 minutes. So now we have obtained the range of SHA in which we have to find the stars and planets of the required magnitude.
So you can see, beta, the only difference in this question is that we have kept the LHA equal to 180. In the last question, it was kept equal to 360. Here it is kept equal to 180 because of inferior meridian. Other than this, the entire question is the same. So any doubts up to here, beta?
ये जो 180 डिग्री से हम लोग कर रहे हैं ना, ये थोड़ा सा बता सकते हैं कैसे 180 पीरियड में 180 कैसे आ रहा है LHA?
ओके बेटा जो LHA होता है ना, LHA, it is the angle between the observer meridian and the meridian passing through the body, right? Mayad westwards. This is LHA.
Okay.
Now, if body is on our inferior meridian, the angle between my meridian and inferior meridian will be 180 degrees, correct?
Yes, sir.
That's why LHA is equal to 180.
Yes, sir. Yes. Okay.
Okay. Inferior meridian, any body on our inferior meridian will have a LHA of 180 degrees.
और सर 360 इसलिए होता है कि वो पूरा घूम के आता है, करेक्ट?
No problem. I'll show you in a rational horizon diagram also. Don't worry. So for now, just remember any body on our inferior meridian has a LHA of 180.
Okay, sir. Okay, got it.
Okay.
The SHA range of interest to us is from 253 degrees 10.6 minutes to 268 degrees 13.1 minutes. We go to the star tables, look for stars in this range with magnitude of 2 and brighter, and we get the following stars. We get Adhara, we get Sirius, we get Elena, we get Canopus, we get Mirzam. So these are the 5 stars that we get, which have the SHAs. You can see they are in this range, and their magnitude you can see here, they are of magnitude 2 and brighter. So these are the stars which shall cross the observer's meridian between 1800 hours to 1900 hours ship time on 21st September for an observer in position 40 degrees 10 minutes north, 121 degrees 15 minutes east. Now we go to the daily pages of the Nautical Almanac for 21st September to see if any of the planets fall in this range of SHA. And we find that Mars has a SHA of 264 degrees 06.2 minutes, which is in this range. So Mars would also be crossing the observer's inferior meridian in the given window. Now, where do we get this SHA of Mars from?
Okay, before we proceed ahead, beta, just have a good look at the solution. Let me know any doubts coming in.
सर हमें सारे स्टार्स चेक करने हैं या फिर जो नीचे में लिखे रहते हैं 4 वाले? सॉरी, नहीं सर, ठीक है, ठीक है, ठीक।
Clear, sir. Clear.
Sir, so one doubt, sir. I mean,
बोलो बेटा.
generally the reference from the planets also, is it from LH Iris, right, sir? Meridian from the Iris only, right, sir? So there is no weightage for GHA of the planets. This question.
Beta, SHA of any body is with reference to celestial meridian of Aries.
Why it is the same in the planets also, sir? Same like stars?
Because बेटा देखो, जो GHA होता है ग्रीनविच आर एंगल, वो चाहे प्लेनेट का हो, स्टार का हो, सन का हो, वो तो ग्रीनविच मेरिडियन से मेजर होता है ना.
Yes, sir. Right.
सेम वे LHA अगर किसी बॉडी का लेते हो, चाहे वो स्टार हो, प्लेनेट हो, सन हो या मून हो, वो ऑब्जर्वर के मेरिडियन से मेजर होता है. एग्जैक्टली इन द सेम वे अगर आप SHA लेते हो, साइडेरियल आर एंगल, तो वो एरीज के सेलेस्टियल मेरिडियन से मेजर होता है. साइडेरियल बेसिकली मींस एरीज.
Okay, sir. Sir, my question is that is it more comfortable to locate that celestial body if the reference is from celestial meridian of the Iris, not from Greenwich?
No, I didn't get you. Can you repeat, Peter?
No, sir. I just have some doubt. Sir, for locating the position of celestial body, I mean, to locate in the rational horizon, why we choosing the reference from Iris, not from the Greenwich celestial meridian on the body and from the observer. It's
Okay,
only
beta.
will take from.
Okay. Why we are using SHA here, SHA range here in this particular question, right?
Yes, sir.
राइट बेटा, उसका बड़ा सिंपल सा रीजन है कि बेसिकली इस क्वेश्चन में आवर मेन एम्फेसिस इज ऑन स्टार्स. ओके, मेन एम्फेसिस इज ऑन स्टार्स. प्लेनेट तो सिर्फ 4 ही हैं, स्टार्स बहुत सारे हो सकते हैं. लाइक इन दिस केस यू सी देयर आर 5 स्टार एंड ओनली 1 प्लेनेट. अगर ये अकेला प्लेनेट की बात होती तो हम GHA भी निकाल लेते इसका. वी कुड इजीली फाइंड आउट व्हाट इज द GHA, राइट? सो बट आवर मेन एम्फेसिस बीइंग ऑन स्टार्स, और जो हमारा स्टार्स का टेबल है उनमें जो स्टार की लिस्टिंग है दैट इज एज पर देयर SHA, नॉट एज पर देयर GHA. दैट्स व्हाई वी हैव फाउंड आउट द SHA ऑफ दीज बॉडीज इन द फर्स्ट प्लेस. नाउ जब हमारे पास SHA आ गया है तो हम सेम क्राइटेरिया को प्लेनेट के लिए भी यूज कर रहे हैं. अदरवाइज यू कुड फाइंड द GHA ऑफ द प्लैनेट्स आल्सो.
Okay, sir. So in these special type questions, we will choose only the SHA of the planets, okay, right, sir, to locate the position.
Right, better, right. Nowhere else in any other calculation you will be taking up the SHA of a planet.
Right. Okay, sir. Thank you, sir.
सर इसमें डिक्लिनेशन मार्स का 23 डिग्री 28.1 मिनट है. सर ये कौन से टाइम के कॉरस्पॉन्डिंगली है सर? जैसे अभी तो 10 बजे और 11 बजे दोनों टाइम पे यही डिक्लिनेशन है. अगर दोनों
राइट
टाइम,
बेटा,
हाँ
राइट. सो
और अगर
आपने देखा अगर 10 और 11 में डिफरेंस भी होता यू कुड पिक अप ए टाइम फॉर 10:30 बेटा.
अच्छा, ओके सर, ओके
ओके, यू कुड पिक अप ए टाइम फॉर द मिडल वैल्यू.
ओके सर.
एनी मोर डाउट्स बेटा?
सर स्टार फाइंडिंग में जब भी मेरिडियन का डिस्कस होता है तो इसमें 3 टाइप के क्वेश्चंस होते हैं ना, ऑन द ऑब्जर्वर्स मेरिडियन, क्रॉसिंग ऑब्जर्वर्स मेरिडियन एंड इंफीरियर मेरिडियन. एनी अदर टाइप्स ऑफ मेरिडियन क्वेश्चंस?
बेटा मैंने आपको 5 डिफरेंट अलग अलग टाइप के क्वेश्चन कराए. पहला वाला था स्टार्स क्रॉसिंग द स्टार्स विद इन ए सर्टेन आर एंगल. दूसरा था आउट ऑफ दीज विच आर सुटेबल फॉर साइट और suitable for visible to the observer or above the horizon. तीसरा था which are suitable for X meridian. All these three basically referring to a certain R angle. फिर जो चौथे टाइप का क्वेश्चन हमने किया स्टार्स क्रॉसिंग ऑब्जर्वर्स मेरिडियन, और जो पांचवें टाइप का किया स्टार्स क्रॉसिंग ऑब्जर्वर इंफीरियर मेरिडियन. विद दीज 5 दिस टॉपिक इज फिनिश्ड. यही 5 मेथड आते हैं बेटा.
ओके सर.
अकेला क्वेश्चन आता है सर, अकेला क्वेश्चन आता है सर पार्ट में ये 25 नंबर का?
नहीं बेटा, पार्ट बी में 3 क्वेश्चन हैं, तीनों 25 नंबर के हैं. एक
नहीं
चॉइस
सर,
होती है.
ये पार्ट ए पार्ट बी मतलब क्वेश्चंस में भी ए भी होता है ना सर, तो एक ही आता है सीधा ना?
दिस इज वन क्वेश्चन फॉर 25 मार्क्स. कंप्लीट वन सिंगल क्वेश्चन फॉर 25 मार्क्स.
ओके
सर, सर एक डाउट था सर.
अब बोलो बेटा, बोलते जाओ.
ब्रो पूछ.
ओके सर, ओके सर, थैंक यू. सर ये प्लैनेट में हमने मार्स का डेक्लिनेशन कैसे निकाला सर? कौन सा टाइम लिया है हमने?
बेटा हमें जो क्वेश्चन में टाइम दिया गया है 1800 टू 1900 शिप्स टाइम. GMT आता है 1000 टू 1100 ऑन 21st ऑफ सितंबर, करेक्ट?
यस सर.
आप इनके बीच का मिडल टाइम 10:30 ले लो और इसकी डेक्लिनेशन निकाल लो.
ओके, तो ये 10:30 का GMT 10:30 का है ये. ओके
राइट बेटा, दैट्स राइट.
So so in the types what you just mentioned, the above one where have you done, sir? Above the horizon.
बेटा L difference D less than 90 are the stars suitable for sight because they are above the horizon. Are the stars which are visible because they are above the horizon. So visible stars or
दोनों
above
का
the
same.
horizon star mean the same thing.
Okay, perfect. Okay, thank you.
That's right बेटा. अगर वो इसमें पूछता है कि इनमें से कौन कौन से विजिबल होंगे, तो हमें इसमें सर्कमपोलर क्राइटेरिया चेक करना पड़ेगा. Exactly बेटा. Yes, you got it
The
right.
declination is great, right? Usually declination should be greater, right?
तो सर्कमपोलर तो उसका वो होगा ना सर, visibility का, लेकिन उसमें फिर सुटेबिलिटी का क्या होगा सर?
बेटा सबसे पहले तो अगर इस क्वेश्चन में वो पूछता है कि कौन से स्टार्स आपको दिखेंगे, तो आपको सर्कमपोलर क्राइटेरिया चेक करना पड़ेगा. ओके. I don't think they will go to the extent of asking you suitable for sight. They will only ask you which of them will be above the horizon. Okay. The questions which have come till now are only inferior meridian, which all will be visible to you. Okay. So that circumpolar criteria will take care. Now अगर आप ये भी जानना चाहते हो कि इनमें से suitable for sight कौन सा होगा, जिसका latitude plus जिसका altitude जो है वो 10 डिग्री से ज्यादा हो, so in that case there will be a little modification. पर वो मैं आपको अभी नहीं कराऊंगा, वो मैं आपको कराऊंगा when we go to circumpolar bodies. I'll explain in the rational horizon diagram in detail.
ओके सर.
ओके.
एक बार वो इंफीरियर एक्सप्लेन कर देना सर डायग्राम में.
इंफीरियर मेरिडियन बेटा
जो पूछ रहा था ना 180 डिग्री 360 डिग्री एक बार.
don't worry. Once after this I'll go to circumpolar bodies. I'll show you inferior meridian and LHA 180 also. Okay, great. So I'm closing this out now, and I'm going to, somebody had some doubts in the assignment, so now I'm going to the assignment questions. So closing this out beta.
The topic खत्म हो गया?
Yes beta, this topic is finished. Stars suitable for sight topic is finished. These were the only 5 types. The question will come based on any one of these.
Oh, thank you.
Okay, great. Let us go to the assignment now.
So are we going to cover any other topic today?
Yes beta, certainly. I'm going to circumpolar bodies. I'm just solving your doubts. We are going to circumpolar bodies now.
Okay.
So beta, assignment, which question you want me to open up?
Question number 4.
Question number 4. Just give me a minute. So here we are beta. Question number 4 is there. On 19th January, DR so and so, find which stars of magnitude 2 and brighter will be available for observation below the pole between 1800 and 1900. This is the one which we did exactly. Yeah, actually in this question, this term which is mentioned below the pole, it basically means the inferior meridian. So it is exactly similar to the one which we did just now.
Yeah.
Okay, so what is the doubt beta? Is the doubt cleared?
So I just wanted to ask you, so remember a few days back you had made this magic diagram. Tabhi that P was there, that was the one that is the depressed pole, right? So that depressed pole becomes a part of this inferior meridian, right?
Okay, I'll show you beta. I'll show you. Just now when I open up the circumpolar presentation, मैं ये सारी चीजें आपको एक्सप्लेन कर दूंगा। इंफीरियर मेरिडियन भी दिखा दूंगा, इंफीरियर मेरिडियन पे LHA 180 होता है वो भी दिखा दूंगा, उसे बिलो द पोल क्यों बोला जाता है वो भी दिखा दूंगा। सो जस्ट वेट फॉर दैट। राइट बेटा, दैट्स राइट। अबव पोल इज ऑब्जर्वर मेरिडियन, बिलो पोल इज इंफीरियर मेरिडियन। मैं अभी आपको डिटेल में भी एक्सप्लेन करता हूँ व्हाई इट इज कॉल्ड सो। सो दैट इज द डाउट्स आर क्लियर बेटा, देन आई कैन एक्सप्लेन यू अबव पोल बिलो पोल।
Yes.
Very good beta, great. So now we had some doubts. How do we get the circumpolar condition? Just a minute, let me remove this. The doubts which we are having is, how do we get the criteria for circumpolar bodies? L and D same name, L plus D should be greater than or equal to 90. How is the LHA 180 when a body is on the observer meridian? Why the observer meridian is called above the pole? Why the LHA is 0 when or 360 when it is on the pole? All these questions we are going to understand now through circumpolar bodies, through a rational horizon diagram. So if you are comfortable, we can start off with that.
Go ahead.
Okay beta, let's go. Just give me a minute, I'll set it up. In this presentation, we are going to learn about circumpolar bodies. The literal meaning of the word circumpolar is making circles around the pole. Now, fundamentally speaking, all the celestial bodies, they move in circles around the pole. All the celestial bodies move on their declination circles, and all these declination circles are centered at the pole only. But as far as the circumpolar term is concerned, we call those bodies as circumpolar whose circular motion is visible to us. The complete circular motion around the pole is visible to us. In other words, a body is said to be circumpolar if the body is always above the rational horizon of the observer. That is, the body should not set. During the full day, the body should not set. These type of bodies are called as circumpolar bodies. They remain above the horizon of the observer, and you are able to visualize or you are able to see them at any time of the day for full 24 hours. Now let's try to understand when does a body become circumpolar, or what are the conditions which lead to a body becoming circumpolar. This can be easily understood from a rational horizon diagram. Now let's assume that our observer is in northerly latitude in the north hemisphere. You can assume latitude close to 40 degrees north or so. And let's make a rational horizon diagram for the observer. We have the rational horizon. We mark off the N, E, S, W points on the rational horizon. Then we mark the celestial meridian of the observer. We mark the prime vertical circle. Exactly at the center of this diagram is the zenith of the observer, represented by Z. Now, since the observer is in the north hemisphere, the latitude is north, equinoctial will be passing south of the observer. So from point Z, if we go down south equal to our latitude, now that gives us the point from where the equinoctial will be passing. It is represented as point Q in the rational horizon diagram. We are aware that equinoctial always passes from west and east points. So now we know that the equinoctial will pass from W, Q, and E. And we can now show the equinoctial in our diagram. We have the equinoctial here. Now, once the equinoctial is there in the diagram, we can also show the pole. In this case, the observer is in north hemisphere, so the north celestial pole will be the elevated pole or the visible pole, and it will be 90 degree away from the equinoctial. So 90 degree away or 90 degree north of the Q point, this is where the pole would lie. So let's mark this point as P, representing the north celestial pole. Now in this diagram, let's assume some celestial bodies of different declinations and let us see whether they become circumpolar for this particular observer or not. Let us first assume a body with a declination opposite to the latitude. The latitude in this case is north, so let's assume a body having a southerly declination. Now in this diagram, we are aware that this N point is on the horizon. The P point represents the pole, and this N to P, what is highlighted by this yellow line, is called as the elevation of the pole or the altitude of the pole. And this is always equal to the latitude of the observer. We can easily understand it from the diagram. Now, the N point is 90 degree away from the Z point, from the zenith, because every point on the rational horizon is 90 degree away from the zenith of the observer. Similarly, the P point, which represents the pole, is 90 degree away from Q point, which is the equinoctial. So P to Q is 90 degrees, that is pole to equinoctial. N to Z is 90 degrees, that is rational horizon to zenith. So therefore, what is the arc ZQ? It will be exactly the same as arc NP. ZQ was the latitude of the observer, so NP, which is the altitude of the pole or elevation of the pole, will also be equal to the latitude of the observer. So let's now assume some celestial body. As I told you, first let's assume a body having a southerly declination. So we have a star here. You can see it is south of the equinoctial, having a southerly declination. Let's try to show the path of this star, the path on which this moves, that is the declination circle of this particular star. All the declination circles are parallel to the equinoctial. So the declination circle of this particular star parallel to the equinoctial would appear something like this. The declination circle shows us the path on which the body moves. Now this body is going to rise at this particular point on the horizon. You can follow the laser pointer on the screen. This is the point where the body is going to rise on the eastern horizon. After rising, it will move on its declination circle. It will cross the meridian of the observer at this particular point and then cross over to the western side, and eventually it will go and set at this particular point on the western horizon. And we can see here that this body is certainly not circumpolar, because at this particular point it is going to go below the horizon of the observer. Now you could have picked up a body of any southerly declination lying between Q and S points, and you will see that all those bodies' declination circle will hit the western horizon at some point, making that body go below the horizon. So any body with a declination opposite to the latitude will not be a circumpolar body. So this is one thing which we have seen now. Now let's assume a second celestial body with its declination of the same name as latitude of the observer and see whether it becomes circumpolar or not. Before I go ahead, beta, any doubt up to here?
Yes, sir. The very last line, what you said, how it will hit the exactly the last part of declination of the declination body.
Beta, I just said that if you have a body with a declination opposite to the latitude, in this case a southerly declination, it will be crossing the meridian between Q and S, and certainly the declination circle is going to hit the horizon between W and S point somewhere. So it will go below the horizon and it will not be circumpolar.
Oh, okay.
Okay. Great. Let's move ahead.
Yes.
So you can see in the diagram, this is the rising point of the body. A body moves in this particular direction represented by the arrow and then eventually sets at this particular point. Now let's assume a second body here. Now this star is north of the equinoctial and the declination of the star is of the same name as the latitude of the observer. Let's try to show the declination circle of this particular star. The declination circle will pass through the body and it will be parallel to the equinoctial. So this is how the declination circle is going to appear. On this declination circle, the body will be moving in this particular direction represented by the arrow. The body will be rising at this particular point, moving in this particular direction, crossing the meridian here, and at this particular point, the body is going to set. So we saw that even this particular body is not circumpolar. So it is not necessary that with lat and dec of the same name, a body should certainly be circumpolar. Let's try to increase the declination a little bit now. Let's assume a third body, this particular star now. This is also having a northerly declination, but the declination is more than what we had in the previous case. Let's try to draw the declination circle of this particular star. Now declination circle will pass from the body and go ahead beta.
सर ये जो नॉर्दर्ली लैटिट्यूड था इसका डेक्लिनेशन था बॉडी का, इसमें सर्कमपोलर नहीं होगा?
हाँ, that's right बेटा. जो ये second star हमने देखा, even though the declination is north, but it is still not circumpolar.
Why sir?
Because it is setting here beta. For it to be circumpolar, it should not set.
Okay sir.
Okay. And now we are going to see a third star. And we are going to now draw its declination circle. It will be parallel to the equinoctial. Now in this case, the declination circle is going to be like this. All the declination circles are centered at the pole. So centered at the pole, polar distance equal to px, pole and the body. If you draw a circle, that gives you the declination circle of this particular star. Now the arrows show the direction in which the star will be moving on this particular circle. Now we can clearly see that the entire declination circle of this particular star is above the horizon of the observer. It touches the horizon at the north point, but never goes below the horizon. So these bodies which remain above the horizon of the observer for full 24 hours and never set are circumpolar bodies. So one thing we have seen from this diagram that it is certainly not possible to have a body circumpolar with lat and dec for opposite names. So one condition which we can pick up from this rational horizon diagram is that for a body to be circumpolar, the first condition is the latitude and declination. Latitude of So any doubts up to here, beta?
So then, sir, just one more doubt.
Go ahead,
So
beta.
then, what about the what about the values of the lat and dex then?
We will go
Because
to that,
at the
beta.
same,
Don't worry,
oh,
we
sorry,
will go to that. Okay, so let me now show you what should be the other condition for a body to become circumpolar. Let's go.
So can you explain the
Now in this
is it 90
diagram,
minus destination?
ask again, beta.
Sir, is it 90 minus declination, sir? Polar
That's
distance?
right, beta. The polar distance is the distance between the pole and the celestial body. It is 90 minus declination. Declination is basically the arc between the equinoctial and the body. Okay, that is
No,
declination.
okay.
Pole to equinoctial
Okay.
is 90 degrees. So the polar distance will be 90 minus declination.
Yes, it is.
Okay. I have also shown the polar distance of the body, P to X. This represents the polar distance of this circumpolar star, and it is always equal to 90 minus declination. So polar distance in this case, which is 90 minus declination, is shown in the diagram. Now we can clearly see in this particular diagram that for a particular body to be circumpolar, the polar distance of the body, which represents the radius of the declination circle, should always be less than or equal to NP. If the polar distance is more than NP, then you can clearly see from the diagram that the declination circle will go beyond the horizon of the observer. It will go below the horizon of the observer, making the body not a circumpolar body. If it has to be circumpolar, the radius of this circle, that is px, should be equal to or less than np. If the radius is equal to np, you will have exactly this particular condition. The circle will be touching the horizon at point n. And if the radius is less than np, then the entire circle will be within the rational horizon of the observer. So we understand from this diagram now that for a body to be circumpolar, this condition should be met. That is, the polar distance of the body should be equal to or less than the elevation of the pole, or NP. Now, NP, or elevation of the pole, is equal to the latitude of the observer. So we now come to this relationship that Px, which is the polar distance, should be less than or equal to Np, which is the latitude. Now polar distance is equal to 90 minus declination. So this converts the relationship into 90 minus declination should be less than or equal to the latitude of the observer. Now if I take declination to the other side, to the right hand side, the relationship becomes latitude plus declination should be greater than or equal to 90 degrees. So this is the second condition which needs to be fulfilled for a body to become circumpolar. The first condition which we saw in the previous slide was that the latitude and declination should be of the same names. The condition which we saw in this particular diagram is latitude plus declination should be greater than or equal to 90. So these are the two conditions which needs to be met for a body to become circumpolar. Latitude and declination same names, and latitude plus declination greater than or equal to 90 degrees. So remember these two conditions for a body to become circumpolar. Any doubts, beta?
Yes, sir, go ahead.
Very good, beta. Great. Let's go ahead. We can, beta, but just hold on for some time. Okay, मैं वो भी explain कर दूंगा. Don't worry, it will come. Now we have seen that when a celestial body becomes circumpolar, it remains above the horizon of the observer for full 24 hours. Now, if the same concept is applied to the sun, that means for a particular observer, if the sun becomes circumpolar, it will mean that the sun will remain above the horizon of the observer for full 24 hours of the day. This will result into what we call as a continuous day or a 24 hours day. In some of the questions, this concept of continuous day or a 24-hour day is used. So in these type of questions, we should be aware that if the sun becomes circumpolar for an observer, he will have 24 hours daytime and no night. This happens close to the poles in higher latitudes above about 66.5 degrees north and south. In the polar regions, you have 6 monthly days and 6 monthly nights. Whenever the sun's declination matches with the declination of a particular pole, it will always remain above the horizon for that observer, leading to 24 hours day. So thus, if the sun fulfills the circumpolar criteria, there will be a 24 hours day and there will be no night for that particular observer. So in case the conditions for continuous day are asked to us in the question, they will be same as the conditions for circumpolar bodies. That is, the latitude of the observer and the declination of the sun should be of the same names, and the latitude of the observer plus the declination of the sun should be greater than or equal to 90 degrees for the sun to be circumpolar, resulting in a 24 hours day or a continuous day and no night at that particular latitude. Any doubts up to here, beta?
So the last sentence is no light at that particular latitude. That's it.
Beta, your voice was not clear. Can you speak again?
I mean, sir, your last sentence was when lat plus declination of sun is greater than 90 degrees, then you'll get continuous day and no night, right, sir, at that particular latitude.
Yes, beta, that's right.
Okay, it means only applicable to only that parallel of latitude, right, sir? That point only.
Exactly, beta. You will have to check it for every latitude. whichever latitude fulfills these two conditions, there only you will have a 24 hours day and no night.
But sir, declination to hierarchy, sir.
Ask again.
But declination will change every hour, na sir? तो
Yeah,
criteria
it
फिर
will
से
change
मान लो
every hour. So the condition whether sun is circumpolar or not will also keep on changing. Today the sun may be circumpolar in the south pole. Tomorrow it may be circumpolar in the north pole. It will keep on changing from day to day, beta.
Okay, sir.
Okay, चलें बेटा आगे चलें.
Sir, this plays only one doubt. But isn't this continuous day term comes from solstice to solstice, where 6 months daylight is in the north and 6 months night in the south?
These are two different phenomena, beta. 6 monthly day and night at the poles is a different phenomena, and a continuous day is only referring to one complete day or 24 hours. It can happen at any place. It can happen at any place from the pole to any latitude above 66.5 degrees.
Okay, sorry, I missed out. Only it's a day. Okay.
All right. Let's go ahead.
Sir, from this figure, can we make out the true?
Ask again, beta. Hello, ask again.
Okay, sir, got it. Good.
Okay, all right, ठीक है बेटा. Now, in some of the questions, instead of asking the conditions for a continuous day or 24 hours day, they ask us the conditions for a continuous night or a 24 hours night. It basically means that the sun should remain below the horizon of the observer for the full 24 hours, and in that case, the observer will have 24 hours night and there will be no day. There will be no sunrise, there will be no sunset. The sun is going to remain below the horizon of that particular observer for full 24 hours. Now, this condition is possible when the following conditions are fulfilled. Number one, the latitude and declination should be of the opposite names in this case. For sun to remain below the horizon or for a continuous night or 24 hours night, the latitude and declination have to be of the opposite names. It is only possible when the lat and dec are of the opposite names. And the second condition is that latitude plus declination of the sun should be greater than 90 degrees. So these are very similar to the circumpolar conditions, only difference being in circumpolar the latitude and declination should be of the same name, and in a 24 hours night scenario or continuous night scenario the latitude and declination should be of the opposite names. We can understand it very easily from the rational horizon diagram. You can see this rational horizon diagram. We have an observer in the northern hemisphere. We can see the pole. We can see the equinoctial as WQE. Now, in this diagram, we are aware that the portion or the arc ZQ represents the latitude of the observer. Q is the equinoctial, Z is the zenith. So ZQ represents the latitude of the observer. Now our first condition says that the declination should be of opposite name to the latitude. So in this case, if the latitude is north, the declination should be south. South declination means that the sun would be below this point Q. So the sun would be southwards of point Q, which represents the equinoctial. The sun will be southwards of the equinoctial. Now, if the sun is between point Q and point S, it has southerly declination, but it will still be coming above our horizon. If the sun passes our meridian between Q to S, it will still be coming above our horizon. There will be a sunrise and there will be a day for some parts of the 24 hours. But if the declination circle of the sun goes beyond point S or further south of point S, then in that case, the entire declination circle of the sun will remain outside our rational horizon and the sun will never come above the horizon. So let me show you in the diagram. If the declination of the sun is such that it has gone beyond point S or southwards of point S in our diagram, you can see the declination represented in maroon, and the declination is such that the sun has gone beyond point S. In this case, the declination circle of the sun, you can see this dotted line showing the declination circle of the sun. The entire declination circle of the sun will remain below the observer's horizon, making it a 24 hours night. There will be no sunrise, the sun is not going to come above the horizon of the observer, and there will be no daylight. Now we are aware that from the Z point to the S point, Z is the zenith, S is the south point on our rational horizon, the total arc length is 90 degrees. From the zenith to the horizon, the arc length is 90 degrees. And we know ZQ is the latitude. Now this is the declination Q to S. So if latitude plus declination is greater than 90, it immediately tells us that the declination circle will pass beyond our rational horizon, or the sun is going to remain below our rational horizon. So that's why the condition latitude plus declination of sun should be greater than 90 degrees for the sun to remain below the horizon for 24 hours, resulting in a 24 hours night or a continuous night. Whenever the sun has a northerly declination, in that scenario, the south pole has a continuous night or a 24 hours night, because lat and dec are of opposite names and the latitude plus declination is greater than 90. The same thing happens when the sun is having a southerly declination. There is a continuous night or 24 hours night on the north pole.
So in this scenario, what you made, their continuous night is in the northern hemisphere, right?
Yeah, go ahead, beta. Can you please ask again?
So now in this scenario, what you made, which is on the presentation right now, either the continuous daylight is in the southern hemisphere and continuous night is in the northern hemisphere, right?
It is not the entire northern hemisphere, beta. It is this particular latitude only. It does not mean that
yes,
right. It is not the
no,
entire.
No, sorry. Yeah. Sorry, my wording mistake. In the north latitude, that will be night, right?
Yes, which fulfill these two conditions. In that particular latitude, you will have 24 hours night.
Correct. So upper night, correct. Okay.
Right. Okay. इसको तसल्ली से देखो बेटा, जो भी डाउट आ रहा है प्लीज आस्क मी. एंड यू आर आस्किंग बेटा, L डिफरेंस D लेस देन 90 पे बॉडी विजिबल होती है, L डिफरेंस D ग्रेटर देन 90 पे बॉडी नहीं विजिबल होती है. सो दैट आल्सो यू कैन अप्रिशिएट नाउ फ्रॉम दिस डायग्राम. If the L difference D is greater than 90, body will go beyond the horizon and it will not be visible.
Sir, again, one more doubt, sorry. So in the same diagram, now what we just discussed, continuous night will be in that latitude. And a minute back, we discussed saying that continuous night will be in that latitude, in in the north side, right? And the
Yes.
body, as we see, is passing, just cutting through the south pole. Means it is
Yes.
below the observer's horizon. So
Right.
from that Q to S, there will be daylight over there.
No. You mean to say the observer is between Q to S, right?
Diagram says.
Observer is
we are
here
having
only.
a continuous. Yes, sir, correct. Observer is there. Continuous
Okay.
night is in continuous night as per this diagram what we made is
Right.
at that latitude in the correct. Now
Right.
considering that body is sun.
Right.
Now when it is passing, so when sun passes there will be daylight, right, at some place. So what is that place? Uska range क्या है? From where to where it will be daylight?
Okay, beta. Okay, I will tell you now. I will tell you. Anywhere on the earth where these two conditions are not being met, there will be some part of 24 hours which will be day.
Okay.
You have the declination of the sun, you put it here. You put any latitude of your choice, just put it here in these two conditions. If it does not fulfill these two conditions, there will be day for some part of 24 hours.
चलेगा, got it.
Okay, beta, got it?
Yes.
Great. और बताओ बेटा, और क्या डाउट आ रहे हैं? Great. So looks like up clear up to here. चलें आगे फिर?
Yes.
Let's go.
Yes, sir.
Let's go. Now going a little more deeper into the circumpolar bodies, we had this particular star and the polar distance is less than or equal to NP in this case, and you can see the entire declination circle of the star is within the rational horizon of the observer. So this is a circumpolar star. Now the direction of this, the motion of the star is represented by these two arrows. Now in this particular diagram, we can see that the star comes north of the observer at two instances. At point A here, it will be north of the observer. The bearing of the star would be 0, 0, 0. And again, when it reaches or crosses the meridian at point B, it will be again north of the observer with a bearing 0, 0, 0. Now this is only possible in case of a circumpolar body. For a normal body which is not circumpolar, it will come north or south of you, or in other words, you can say it will come on your meridian only once in a day. But a circumpolar body will be north or south of you twice in a day. Roughly after an interval of 12 hours, it will be south or north of the observer 2 times in a day. Now both of these instances are called as meridian passages. One of them is the meridian passage on the observer meridian. If you look carefully in the diagram, P is the pole and P, Z, Q, S is the observer's meridian, and you can see that at point B, the body crosses the meridian of the observer. Now at the second instant, that is at point A, it is crossing the inferior meridian of the observer, or the opposite meridian of the observer. You see, when you go on other side of the pole, this represents your inferior meridian, reciprocal meridian. So at point A, the body crosses the inferior meridian of the observer. At point B, it crosses the meridian or the observer's meridian. Now point A is known as meridian passage on the inferior meridian. You can call it the meridian passage of the body on the inferior meridian, or You can also call it meridian passage below the pole. Now, why do we call it meridian passage below the pole? That also can be seen easily from this diagram. We know N to P is the elevation of the pole or the altitude of the pole. So N to P represents the elevation or altitude of the pole. N to A represents the elevation or altitude of the body at the time of meridian passage on the inferior meridian. And we can clearly see that the altitude of the body is lesser than the altitude of the pole. That is why at this particular instant, that is at point A, the meridian passage of the body occurs below the pole. Now this is, for this particular reason, this is also called as lower meridian passage or lower Marpas. At the same time, the point B which you see is known as the meridian passage on the observer's meridian. Point B represents the meridian passage on the observer's meridian. It is also called as meridian passage above the pole, because you can see at this point the altitude of the body is represented by NB, November Bravo. The altitude of the pole is NP, November Papa, and the altitude of the pole is less than the altitude of the body. The body is at a higher altitude at point B. So that is why it is called as meridian passage above the pole. And it is also known as upper Marpas or upper meridian passage, because at point B the body is above the pole. It is at a upper location than the pole. So upper Marpas and the lower Marpas. Upper Marpas or meridian passage above the pole is on the observer's meridian. Lower Marpas or meridian passage below the pole is on the observer's inferior meridian. Now, if you remember, when you look for the meridian passage time of the moon in the almanac, there are two times which are given, one under upper and other under lower. This upper and lower basically means the meridian passage of the moon on the observer's meridian, that is for upper, and for lower, it is the meridian passage of the moon on the observer's inferior meridian. Any doubts, beta?
Sir, can you explain that NA, sir, that this altitude of the body at inferior meridian is less than the altitude of the pole, that section?
Okay, beta, I'll do that. See, point N is on the horizon, right? N, E, S, W, all these points are on the horizon. The circumference of this diagram is the horizon, correct?
Yes.
Point A is where the body is right now, correct?
Yes, sir.
So the arc of the meridian, or basically the arc of the vertical circle, which lies between the horizon and the center of the body, is the altitude of the body. So NA is the altitude of the body, right?
Yes, sir.
And the altitude of the pole is arc of the vertical circle contained between point N and the pole. NP is the altitude of the pole. So which one is bigger, beta? NA or NP?
Sir, NP, sir.
NP is bigger. That's why point A is called lower Marpas or meridian passage below the pole.
Sir, can you call the NA true altitude, sir? NA?
That's right, beta. It is the true altitude.
For other general questions, sir, which we are doing in EL, we are using always moon's upper Marpas, right?
That's right, beta. For all normal questions where they talk of Marpas, we consider the upper Marpas. If in a question they tell you it was on the inferior meridian, then only you pick up lower Marpas.
So we were doing like that, but today we understood why we are doing it.
Okay, right.
Sir, this upper mer pass, lower mer pass, why only for moon, sir? Why not for other celestial bodies, sir?
It happens for other celestial bodies also, but your question is why it is given in the almanac only for moon, right?
Yes, sir.
The reason for that is for other bodies, for sun as well as planet, it occurs exactly after about 12 hours. So if you have one time, you can add or subtract 12 hours, you will get the other time. But for moon, it doesn't happen after 12 hours. For moon, it happens at different times every day. That's why it is given for both the times for moon.
Okay, sir. Okay.
Once we are done, can you also explain how twilight varies with latitude?
Sure, beta. We will do twilight in detail. Don't worry. Next topic. Okay. So comfortable. चलें आगे.
Yes sir, comfortable.
Okay, all right. आवाज थोड़ी धीरे धीरे आ रही है. Okay, anyway, let me see. Just a minute. Let me see what do we have ahead. Okay. अब बेटा मुझे एक बात बताओ before I proceed ahead. हमने आज स्टार suitable for observation का टॉपिक भी कंप्लीट कर लिया है. So now you will be able to attempt your assignment number 4 completely. So sorry, the assignment for assignment number 3, that is the assignment of star suitable for sight, वो आप पूरी कर पाओगे. आज हमने circumpolar body से related concept भी देख लिए हैं, हमें conditions भी पता चल गई हैं. Now we have a option. अब हम circumpolar bodies के questions में enter कर सकते हैं. These questions are based on the rational horizon diagram. Now tell me one thing. आज ये question हम लोग शुरू कर दें? Are you comfortable? High level alarm तो नहीं आ गया बेटा?
नहीं सर, कर लेते.
Alej is there?
सर पहले असाइनमेंट पूरा कर लें सर. ये असाइनमेंट बचा हुआ सर. It will be too much mental.
Yes sir, yes.
अब मुझे लग रहा था तुम्हारी आवाजों से थोड़ी डाउन हो रही हैं आवाजें. So there is no issue. If you want to complete this assignment first, we can do these circumpolar numericals in the next class also. No issues. We have time.
सर आप असाइनमेंट भेज दीजिए, हम लोग उसमें एक बार गो थ्रू हो जाएंगे. अगर कंफर्टेबल होगा तो उसको आगे फॉरवर्ड करेंगे.
हाँ, इसको
कौन
और
सी
भी भेज
बेटा?
दो सर, आगे के भी भेज दो इसको.
आगे की असाइनमेंट मैं अभी नहीं भेजने वाला हूँ बेटा. अभी नहीं भेजने वाला. आगे की असाइनमेंट मैं भेजूंगा once I cover up a couple of more topics with you. क्योंकि वो जो
नहीं
असाइनमेंट है
खाली
वो
इसको भेज दो सर, जो बोल रहा था ना इसको भेज दो खाली.
इसको सर, इसको अलग से व्हाट्सएप पे भेजना सर आप. फिर हम पूछेंगे
पहले हम लोग क्वेश्चंस लगा लेते हैं. अभी ये काफी है सर. ये आइडेंटिफिकेशन ऑफ
और क्या सर,
स्टार
अभी
एंड
वही
यू शुड गो अहेड, अदरवाइज इट विल बी मेस.
आपने
Yeah, I got
असाइनमेंट
it. मुझे थोड़ी
कराया
सी
था
ये
सर.
या मुझे ये इंडिकेशन लग रही थी कि इट शुड नॉट बी टू मच ओवरफ्लोइंग काइंड ऑफ स्टफ. सो अभी तक जो किया बेटा वो समझ में आ गया?
हाँ सर.
ग्रेट. सो जो डाउट्स आपके मन में आ रहे थे, इंफीरियर मेरिडियन पे हमारे पास क्या होता है, हमारे मेरिडियन पे क्या होता है, सर्कमपोलर की कंडीशंस क्या होती हैं, ओके, वो सारे के सारे डाउट आई होप दे आर रिजॉल्व्ड अप टू हियर नाउ.
यस सर.
वेरी गुड बेटा, ग्रेट. सो व्हाट वी विल डू इज वी विल स्टॉप हियर फॉर टुडे. हमारी जो सर्कमपोलर बॉडीज का कॉन्सेप्ट है ये क्लियर हो गया है. एंड सर्कमपोलर बॉडीज के कुछ एक प्रैक्टिस क्वेश्चंस जो हैं ये मैं आपको नेक्स्ट क्लास में कराऊंगा. सो इन द नेक्स्ट क्लास मैं आपको अभी बता देता हूँ व्हाट वी आर गोइंग टू डू. One, we are going to cover up the numericals based on circumpolar bodies. इस पे जो numericals आते हैं, these are rational horizon diagram based numericals. So ये हम cover करने वाले हैं. And after that, ये जो अब हम क्वेश्चन कर रहे हैं बेटा, दे कम इन क्वेश्चन नंबर 8 एंड 9. 8 एंड 9 दोनों में ये आता है. ओके, so we will be doing circumpolar bodies questions and after that we will be doing twilight. मैं पहले twilight का कॉन्सेप्ट आपको समझाऊंगा और फिर twilight से रिलेटेड कुछ एक न्यूमेरिकल्स देखेंगे. So this is what we are going to do. Okay, so ये हमारे नेक्स्ट टाइम के लिए दो टॉपिक्स जो हैं, आई होप वी विल बी एबल टू कंप्लीट दीज टू. फिर उसके बाद जो टॉपिक आएगा दैट इज अनदर इम्पॉर्टेंट टॉपिक, दैट इज द टॉपिक ऑफ टाइम. ओके, सो उसके बाद का भी रुक जाते हैं. सो यू गेट ए लीड ऑफ व्हाट वी आर गोइंग टू डू. सो आज के लिए आप प्लीज जो स्टार सूटेबल फॉर साइट की असाइनमेंट है उसे तसल्ली से कंप्लीट कर लो. डोंट कीप एनी होमवर्क पेंडिंग because otherwise if the topics get mixed up तो फिर confidence नहीं आएगा बेटा, then everything will get jumbled. So please complete the star suitable assignment for today, right?
Sir, yeah. I have one more doubt.
बोलो बेटा.
Sir, and the same figures are you shown before, that is the star is on the declination circle. So can you show that how the LHS star is up to the inferior meridian is coming 180 degree, and then let's say Aries plus LHS star is 180 on that case. The case of inferior meridian.
Okay, मैं अभी आपको व्हाइट बोर्ड पे दिखाता हूँ. Okay, so what latitude you want to take? वही रखें 40 north?
Yes sir, वही.
Okay, let's keep the same latitude 40 north. So we have the equinoctial, this is WQE. The pole would be here, this is the pole. अब बेटा एक चीज का ध्यान रखना, इसमें जो ऑब्जर्वर मेरिडियन है, ऑब्जर्वर मेरिडियन मैं आपको अभी शो करने वाला हूं. ऑब्जर्वर मेरिडियन इज दिस वन, PZQS. जो ये मैंने ग्रीन कलर में हाईलाइट किया है, दिस इज द ऑब्जर्वर मेरिडियन पासिंग फ्रॉम द पोल एंड पासिंग फ्रॉम द जेनिथ. ओके,
यस
ओके. अब जो मैं आपको शो करने वाला हूं वो ऑब्जर्वर का इंफीरियर मेरिडियन है. रेड कलर में जो मैंने हाईलाइट किया है P to N, this is the inferior meridian of the observer because you have gone on other side of the pole, right? Great. Now we assume that there is a body on the inferior meridian of the observer. There is a body. Let us put a body here. ये हमने एक स्टार डाल दिया बेटा यहाँ पे. ये एक स्टार है जो हमारे इंफीरियर मेरिडियन पे है. अब इस स्टार का हमने LHA निकालना है. LHA, so let us see how we find the LHA. Let's pick up blue color. LHA is the angle at the pole, so angle will be made at the pole contained between celestial meridian of the observer, that is the green line, and the celestial meridian passing through the body, that is the red line, measured westwards. This is the westerly direction. So from the observer meridian measured westward up to the celestial meridian of the body, this is the LHA, and you can clearly see in this case this will be 180 degrees.
It's correct.
क्लियर बेटा, हो गया क्लियर?
Yes, clear.
वेरी गुड. और बताओ बेटा, और कोई डाउट?
सर ये जो क्वेश्चन नंबर 7 का है सर, जो स्टार सूटेबल है, उसमें सर थोड़ा डाउट था.
क्वेश्चन नंबर 7 अभी ओपन कर लेते हैं बेटा. जस्ट गिव मी अ मिनट.
सर मुझे बस ये जो कंटिन्यूअस नाइट वाला जो था उसका बस एक स्लाइड का एक बार दिखा दीजिए सर.
कंटिन्यूअस नाइट, ओके बेटा, आई एम शोइंग यू. जस्ट अ मिनट. पहले मैं इनको सवाल नंबर 7 पर अप करके देता हूँ. क्वेश्चन नंबर 7. ओके, ये रहा क्वेश्चन नंबर 7 आपकी कंप्यूटर स्क्रीन पे. Says 15th June 92 position so and so, which all stars and planet will be within 15 degrees, which of them will be available for observation, which can be used for X meridian. Observation is to be made at the end of PM civil twilight. बोलो बेटा क्या डाउट है?
सर ये सॉल्यूशन पूरा कंप्लीट हो गया सर. इसमें जब भी एल एंड डी निकाला, एल डिफरेंस डी, तो 83 डिग्री आया है. और सर जो फॉर सुटेबल फॉर ऑब्जर्वेशन का जो क्राइटेरिया है, एल डिफरेंस डी शुड बी लेस देन 80 डिग्रीज. तो
राइट
सर
बेटा.
इसमें 83 डिग्रीज है, तो अगर ये सुटेबल फॉर ऑब्जर्वेशन नहीं है तो ये सर एक्स मेरिडियन के लिए सर ये कैसे सर हो सकता है सुटेबल?
Yeah, that's right बेटा, you are right. This should be a cross.
अच्छा सर, इसमें मिस्टेक है. मुझे वही लगा कि सर हो सकता है मैंने कुछ गलत
हाँ,
किया,
it
बस
is
वो डाउट
83 degrees. It should be less than 80. That's
और
right.
सर ये कंप्लीट हो गया सर. इसमें एक जो स्टार आइडेंटिफिकेशन वाला है सर, वो मैंने ग्रुप में एक क्वेश्चन भेजा हुआ है जो मई 2022 में आया है. इसमें
Right.
मरीन गुरुकुल का वीडियो देख के तो वो वाले कर लिए. ये वाले क्वेश्चन में सर सीएल दुबे में 4 पार्ट फॉर्मूला सीखी हुआ है, तो
No
समझ में
problem बेटा, आप बिल्कुल मत घबराओ. उसके लिए अभी थोड़ा सा रुक जाओ. लेट मी कंप्लीट ए कपल ऑफ मोर क्वेश्चंस. ट्वाइलाइट और एक दो कॉन्सेप्ट और कवर करने दो, फिर वो भी क्लियर हो जाएंगे. डोंट वरी, अभी टेंशन ना लो. 4 पार्ट फार्मूला नहीं चाहिए.
ओके ओके सर. ओके सर.
ओके ओके, और बताओ बेटा, और डाउट?
So I just wanted to ask, no, it's not a doubt. So the topics which will be covering this circumpolar bodies twilight. So ये second med से related same ही रहेगा कि थोड़ा different है?
बेटा सी, जो ट्वाइलाइट का कॉन्सेप्ट है वो तो वही है जो बुक में दिया गया है और जो आपने सेकंड मेट्स में भी पढ़ा होगा, पर उस पे रिलेटेड जो क्वेश्चंस आते हैं दे आर स्लाइटली डिफरेंट. सेकंड मेट्स लेवल यू मे नॉट गेट कॉम्प्लिकेटेड क्वेश्चंस, बट फेज 1 में तो आपको हायर लेवल के क्वेश्चंस आएंगे बेटा. सो दैट डिफरेंस इज देयर. You will get tricky questions as compared to second mates.
So, and one more thing. So, in case in your next lecture, can you spare out time for maximum azimuth also? Because अभी हम लोग सब यही कर रहे हैं तो वो भी concept आ रहा है ना.
किसका concept बेटा?
Maximum azimuth.
Maximum azimuth. Okay. Don't worry बेटा. Let me cover up twilight and a couple of practical questions, rational horizon questions. मैं वो भी आपको समझा दूंगा. Just remind me, okay? After maybe about 2 classes, third class में we will do. Don't worry.
And so one more last. So how much are we remaining now in terms of examination in our portion?
Okay बेटा. So अब बेटा ये अगर ना भी समझ में आए, it is perfectly okay. मैं सिर्फ आपकी इंफॉर्मेशन के लिए बता रहा हूँ कि हमारा क्या क्या टॉपिक्स बाकी है. हमारे बाकी हैं बेटा, जस्ट ए मिनट लेट मी. एक तो हमारे बाकी हैं सर्कमपोलर के न्यूमेरिकल्स, उसके बाद है ट्वाइलाइट के ट्वाइलाइट कॉन्सेप्ट एंड न्यूमेरिकल, उसके बाद है टाइम चैप्टर. ओके, टाइम में सम डेफिनेशंस वी हैव टू डू, एंड फिर उसके बाद हमारे हैं क्वेश्चंस विच आर बेस्ड ऑन, बेसिकली 2 टॉपिक हैं हमारे. These 2 topics are, one is questions based on Kepler's laws of planetary motion, and then questions based on construction of chart. So with this we are going to complete the syllabus. These are the only topics which are remaining.
PZX triangle के numerical कौन है?
हाँ बेटा आएंगे, when we do twilight उसमें PZX के numericals भी आएंगे.
Okay, तो मतलब वही वाले हैं सर, बस अलग से नहीं.
Yes आएंगे. नहीं, they are other than PZX also. They are there, but they will come बेटा, आएंगे.
Okay,
बहुत ज्यादा ऐसा सिलेबस तो थोड़ा कम कर देना चाहिए मैम.
ओके, और बताओ
आखिरी
बेटा.
बार पढ़ रहे हैं
सर वो कंटिन्यूअस नाइट वाली स्लाइड दिखा देंगे अगर
कंटिन्यूअस नाइट स्लाइड अभी लो बेटा. Okay beta, here it is, continuous night.
ओके सर.
ओके,
एग्जाम में सर जो ये आपने समझाया क्लास में, इसकी अंडरस्टैंडिंग पर डायग्राम बना के अगर अपने शब्दों में भी लिख दें तो भी चल जाएगा ना?
हाँ बेटा, you can write in your own words. वैसे theory based question नहीं आते हैं, so ये understanding जो है this will be used in a numerical question. We will be doing numerical question, वहाँ सब use होगी बेटा.
अपने कुछ एक दो थ्योरी के क्वेश्चंस थे सर रिगार्डिंग द सेम टॉपिक व्हिच वी हैव पास्ट पेपर्स में था, ये कंटीन्यूअस diagram and explain with the
Dhruv, I think
sketches something.
Yes, certainly.
assignment
Make
one
this
also कर लो.
diagram, explain in your own words. Perfectly all right.
क्या कह रहा है कुणाल भाई?
Dhruv, assignment one में भी यही क्वेश्चन था, continuous
हाँ.
twilight, that.
Yes, yes.
Okay. So any more doubts?
No.
Okay, beta. Great. So let's call it off for today. You have your homework now. Please complete the star suitable for sight. And next lecture we move on to twilight and we do circumpolar numericals.
सर 3 क्वेश्चन तो सर CL वाले के ही बचे हैं सर, पहले वाले.
Yeah, that's right. We are left with only 2 questions now, 8 and 9.
नहीं आपने सर, हम लोग असाइनमेंट 2 जो दिया था ना उसमें 3-4 क्वेश्चन बचे.
Oh. ओके, कर लो बेटा, कर लो. कंप्लीट है.
नहीं सर, क्या है ना सर, बाकी सब्जेक्ट होते हैं तो थोड़ा सा सर वो हो जाता है, थोड़ा कंटिन्यूस नहीं हो पाता सर.
ये तो करना पड़ेगा बेटा, स्वर्ग जाना है तो मरना पड़ेगा भाई.
कर रहे हैं सर, कर रहे हैं सर.
करने से होगा ये तो.
एटलीस्ट नेक्स्ट क्लास में स्टार साइड के आधे तक तो कर लेंगे सर.
ओके, ठीक है बेटा. ऑल राइट.
Okay, sir. Have a good Sunday.
So see you बेटा. We call it off for today. See you in the next class. Bye bye.
Okay,
सर, जय हिंद सर, जय हिंद.
जय हिंद.
And